Hi everyone, this is Srikanth, and in this video we will be taking up this particular problem. It's been a long time since I've made any video, so I'm sorry. Please pardon me if I'm making any mistakes here and there. Okay, so we have a rigid body rod here, the way it is being shown in the figure here, and it is carrying a negligible, a weight of W here, and it's located at a distance x from this point, which is B. The angle of this rod is at theta with the horizontal. The contact point here is B. There is a roller A here, which is just supporting the rod here, and there is a load located here on the right side. So we have been asked to find the distance x. This is the distance that we have to find. We have to find the distance x such that this particular rod, it will be in equilibrium. So the way to go forward with this is we'll just have to find all the reactions. So in yellow I'll be marking all the reactions. So because the friction is negligible, the reaction here will be perpendicular to this surface. Let's call this reaction as RB, and then over here this reaction RA, this is again going to be perpendicular to the rod, because this being a roller, the reaction point is going to pass through the center point of the roller, which will make it perpendicular to this particular rod. Then we have the load here. The weight of this is going to be falling straight downwards, and because the weight itself is given, weight will be in newtons, so we can just call it as W. In case mass will be given, we'll have to just take it as m into g, mass times the acceleration due to gravity. But since here it is directly called as weight, we can just take it as it is. Now we'll just have to take this and apply the equations of equilibrium. Now when we see the equations of equilibrium, there are actually three equations that we can apply. The first one being sigma v equals 0. Sum of all the vertical forces should be 0. Sum of all the horizontal forces, all the horizontal components should be 0. And sum of moment about any point, that is going to be 0. So this equation, this single equation, is capable of generating as many equations as we want. So okay, so here RB and RA are the two reactions, so we'll probably have to find them first. Is there any way to express RA in terms of W? Yes, I think if we take sigma V equals to 0, this one, RB will not come into our equation. We will just have RA and W. That means we will be able to define RA in terms of W. Once that is done, we can take a moment, and yeah, because x is a distance, so a distance will be included in the moment, so we'll have to take this. So this equation and this equation we'll be using. So let's go ahead with sigma V. Let's take all the vertical forces. Now here, if you observe here, this angle here is going to be theta. Why? Because if there are two lines, and if we draw perpendicular lines to both of these, then these will have the same angle over here. So if we look at our actual diagram over there, okay, so this is perpendicular to this line, and this line is going to be perpendicular to the horizontal from where this angle is measured. So both these perpendiculars will again have the same angle theta. So let's go ahead and solve this. So sigma V, when we are taking, we'll have to take vertical component of RA, and this is going to be cos because this is adjacent. So this is RA cos of theta. So I have made one more video in case you are confused with whether to take sine or cos. I've made another video for that. You will probably get it in the description. I'll add it. You can watch it. Since this is going to be upwards, it's going to be positive, and then we have W acting downwards, so it's going to be negative. There are no other forces acting on this, so the total of this has got to be equal to 0. So now when we take RA value, minus W will go that side, becomes positive, and this comes into denominator. So W by cos theta is the value of RA. So this value we'll have to take, and we'll have to apply it in the moment. So let's take moment, and we'll take moment about this particular point, B. So moment about B we'll have to take. So let's take all the moments one by one. So RA multiplied with the distance. So the horizontal distance here has been given as B. but we want this distance over here. So in order to find that distance, we'll just have to use our triangle. So we have a triangle like this over here. This angle is theta, this is b, and we are interested in finding this length. So we have the hypotenuse and the base. So hypotenuse and base comes in cos theta. So cos theta is base by the hypotenuse, what we want to find. So let's call it as h. So if we say h will be equal to b divided by cos of theta. So this length here will be b divided by cos of theta. So RA times b divided by cos of theta, this will have to take, and because this is going to rotate it in a anti-clockwise direction, so we'll just take it as negative. Then let's take w. So we'll have to actually take this component of w. Now once again this angle is going to be theta, so this is adjacent, so we'll get it as w cos of theta. This is the component, and this component, the perpendicular distance is x, so let's multiply this with x, and this is going to rotate the beam in clockwise direction about this point b, so this is going to be positive. So RB is going to be passing, RB is actually passing through B, so that will not have any moment acting. It will not result in any moment. So this total is going to be equal to 0. So now we are interested in finding the value x. So okay, so x will be equal to this whole term. If you shift to the other side, it becomes positive. Let's take it. Okay. And then this whole term should be, this will come in denominator. So w cos theta will come in a denominator. Now RA value we have just found. Let us substitute this. So we get w by cos theta into b by cos theta into 1 by w cos theta. So w and w is going to cancel. So we get something like b divided by cos cube theta is equal to x. So determine the distance x for any given value of theta such that the rod will be in equilibrium. So he is asking the value of x when theta has been defined. So theta, as soon as you know the value of theta, you can substitute it here and find the value of x. And this value of x, which is given by this particular equation, will exactly tell us the distance of this weight w at which the rod will be in equilibrium. So I hope this video was easy to understand for you. If you have any doubts, or if you want any other types of questions to be solved in the videos, in the coming videos, please give me this question, put it in the comment below, and I'll try to solve it out in the coming time. And okay, that's it. Thank you.